All right, so this is page 4. We're going to continue factoring the special cases of a difference of squares where both of the terms are perfect squares and there's a subtraction sign between them. This does not work unless it's a perfect square minus another perfect square. Something else I want to remind you of. You already know that the square root of x squared is x. You just cut the 2 in half. It also works for other exponents. Remember, as long as it's an even exponent, all you do is cut it in half. Remember our simplifying radicals unit? That the square root of x to the 6th is x. Oh, I'm sorry, I didn't mean to put another square root symbol. The square root of x to the 6th would be x cubed. If you saw something like the square root of x to the 9th, it is not x cubed, because remember, it has to be half of that exponent. X to the 9th is not a perfect square, so we wouldn't be able to use this for an odd exponent. It has to be an even exponent. So very quickly with number 15, I have a perfect square here, but I do not have a perfect square here. So I cannot use this method. The 2's are perfect squares, but that 5 is not a perfect square. So again, if you cannot factor it, we say that it is prime. Number 17, that's a perfect square because 6 is an even exponent and 16 is a perfect square. So now I'll set it up. I'll put my plus sign and my minus sign. Now, the square root of k to the 6th is k cubed. So I need to make sure to put k cubed for both of those. The square root of 16 is 4. So this is factored for this polynomial. This one, perfect square minus a perfect square. So set it up. Put my plus sign and my minus sign. The square root of 121 is 11. The square root of r to the 6th is r cubed. So 11r cubed. Square root of 1 is 1. Notice that with all of the ones we've done so far, there have only been 2 factors. For all of those that we've done on the top part of this page and also on page 3, they only have 2 factors. Each one of these sets of parentheses is considered a factor. But sometimes you can have 3 factors. So let's look at the ones down here where it says multi-step factoring. You are going to have to factor out a GCF first. So this kind of combines pages 1 and 2 with pages 3 and 4. So look at number 21. Number 21, 24 is not a perfect square. 54 is not a perfect square. But if I factor out a factor from, let's say, a 6, if I factor out a 6 from the 24 and the 6 from the 54, there's my 6. Now what I've got is, what 24 divided by 6 is 4. And then I'll keep the a squared. And if I factor out, or if I divide negative 54 by 6, that leaves me with negative 9, but I keep my b squared. So this is like what we did on pages 1 and 2. We just factored out a GCF. 6 can divide out of both of those. 6 is a factor, so I need to remember to keep that as one of my factors. But I'm not done because I've got a perfect square minus another perfect square. So to write the other 2 factors, because this is going to have 3 factors as an answer, I set it up. The square root of 4a squared is 2a. The square root of 9b squared is 3b. So again, if there's a GCF that needs to be factored out, then you need to factor it out first. You always have to factor out GCFs first. And that theme is going to continue for the rest of this packet. So just get used to doing that. Look at number 23. 45 is not a perfect square. Q cubed is not a perfect square. So let's see, what is it that I can factor out of both of these so that I am left with a perfect square minus a perfect square? Well, I know I can factor out of 5 from both of these. If I divide 45 by 5, it gives me the 9, and 9 is a perfect square. If I divide 20 by 5, then that gives me a 4, and 4 is a perfect square. So 5 is my number that I need to factor out. So there's my 5. Now, the other thing I can factor out, see how both of these have Q? I can factor out one of those Q's. I'm sorry, I messed up right here. Let me, I can factor out a 5Q from both of these. So 5Q is one of my factors. If you divide 45Q cubed by 5Q, you're left with 9Q squared. There's your perfect square. Minus, because negative 20 divided by 5 is negative 4, but the Q's cancel. So now we have 9Q squared minus 4, perfect square minus perfect square. So the 5Q remains one of the factors. But now I'm going to set up the difference of squares. So now we've got the square root of 9Q squared is 3Q. Oh, I forgot to do my plus and my minus. And then the square root of 4 is 2. So the final answer is this factor times this factor times this factor. Number 25. Okay, number 25 has 100, which is a perfect square, and 36, which is also a perfect square. So I'm going to leave those alone for right now. But the b cubed is not a perfect square, and b to the first is not a perfect square. So if I factor out the b, then I'm left with a difference of squares. So if I factor out a b from this and a b from that, then I'm left with b, and I'm left with 100b squared from the first term. These b's cancel, so now I'm left with 36. So you can see that what's left after I divide out that b, or factor out that b, I'm left with a difference of squares, perfect square minus perfect square. So don't forget your first factor, that b. Now I'll set it up with my plus and my minus. Square root of 100 is 10, and square root of b squared is b, so that's a 10b. 36, the square root is 6. So it's b times 10b plus 6 and 10b minus 6. Number 27 has 2 variables, and the y is not a perfect square. Neither is the coefficient. Neither one of those coefficients is a perfect square. But if I divide, I can divide both of these by a 4. But that's not going to help me, because if I divide 8 by 4, I'm left with a 2. 2 is not a perfect square. If I divided 32 by 4, I'm left with 8. And 8 is not a perfect square. But if I divide both of those by a 2, then I am left with 2 perfect square coefficients. The other thing I can factor out is the y. This one's a little bit complicated. So if I've crossed the line from you understanding what we were doing to now you don't understand, then you might want to just stop and practice a little bit before you move on. But anyway, so I'm factoring out a 2y. I'm going to open parentheses. 8 divided by 2 is 4. The y's cancel, so I'm left with x squared. So here's my perfect square factor, or my perfect square term. 32 divided by 2 is that negative 16. 16 is a perfect square. 3y cubed divided by 1y leaves me with y squared. So now it is a perfect square. So I will go over here and write my answer. 2y, that factor. Set it up with a plus sign and a minus sign. Square root is a 2x. 2x. Square root here is a 4y. I'm going to skip on down to number 31, and then I'll stop this page. I can factor out an m and an n on both of these. So mn is getting factored out. When I factor out an mn here, I'm left with 3 minus 1. I'm left with m squared. The n's cancel. That's a perfect square. This was not a perfect square. mn is not a perfect square, but when I divide it by mn, it turns into a 1, and that's negative. So this is now a difference of squares. So I'm not done factoring yet, because this is a perfect square minus a perfect square. So here's my first factor, mn. Now I'll set up the rest of it. Square root of m squared is m. Square root of the 1 is 1. Oh, this is supposed to be a minus sign. Sorry, getting ahead of myself. So mn times m plus 1 times m minus 1. Whew. All right, so that's the end of page 4.